today we are going to talk about the logical agent, and the idea of logical agent is this. You know that humans are actually very logical, and they want to do something. They actually do. They apply some logic to find out some new things. So if you want to make a logical agent, so how to do that? Till now we have only talked about that if you want to make an agent that it does the right thing. But right thing means whatever is you are going to whatever information you are going to present him, he is going to do based on that. But what about new things? If I have given some information and based on that some more things can be derived. So whether my agent is will be able to do that or not. So how to make that possible? So in the today's class, we are going to talk about the logical agent and how the logical agent can be made. So welcome once again. This is the lecture number 8 of artificial intelligence course, and it is a flip mode course. So we expect that the uh, course material that is provided to you, you are also going through with them. So let me start by saying this, that human seems to know the things in terms of the any kind of system. If you want to analyze, so if there is one system and there is one human, if you want to find out the difference between them, so you can see that looks like that the human have some kind of knowledge in them. So because they have some knowledge, they can think or they can reason about something. So this is an important part, that how to impart knowledge into the system, and when we have the knowledge, how to do the some kind of inference on that. So if you want to make a knowledge based system, it requires two things. One, what is the knowledge? So first you provide that what all the knowledge that he has, and then there must be an inference engine that actually works on this knowledge to deduce something, that what can be done on that, what is mean by that. Because if you have a knowledge, as I think discussed into the first lecture, that knowledge is actually generalization of some concept. So if you have the general idea of something, so in a specific cases, if you want to apply something, you have to do some kind of understanding on that. So these two things which actually so these two things in essence they becomes a single system. In essence they become a single system. This is the part that is going to do something. So in this, what are the things? Two things. One is the knowledge and another is the inference engine that actually works on that. And if you want to build a system, so you can think that inside the system, inside the complete thing which you are going to consider, there would be some environment. Okay. And in this environment you want to you want that this system should work. So this is the only knowledge based agent part. Okay, so how to find out the how to inference it, how to find out right things. So if you want to make the complete system, you also need a wrapper. This wrapper actually try to find out that what is there inside the environment. First is senses, and that then provide this information to this inference engine, that this is the situation that I am in. Can you tell me what to do? So this inference engine would be doing something and finding out the solution. Here this inference engine. This is going to contact knowledge base, and based on this, it is going to find out that what he have to do. And then after that, he tells to the system that do this particular part. To do this particular part, how, because it's an environment, how to interact with the environment. So definitely there will be some actuators that you actually are going to control them. So you are sending appropriate signal to the actuator, and then when the actuators are going to be going to start, are they going to actuate, then the state of the environment changes from one state to another state. So am I able to give you the broad idea? Am I able to give you the broad idea?
Yes,
Okay.
sir.
Is there any
Yeah.
questions? So the basic idea is very simple, that if you want to make a knowledge based system, so this architecture is needed. This architecture has some knowledge in some form, and this is domain specific, because knowledge cannot be very general. Knowledge is always domain specific. So domain specific knowledge is going to come to you, and then you are going to build an inference engine on that. And inference engine can be very general also, because if any kind different kind of knowledge is also there, then on that also you can apply the inference engine. So this second part is actually domain independent. This and these two parts are actually the core component of your any knowledge based system. Okay, for the logical agent. So this is the complete logical agent that I wanted to talk to you. That this is a complete logical agent. It must have something that need to act. So it senses the thing, and then you provide something input, and then you can go ahead on that. Okay. So, so as I told you that there are three different tasks. One is the telling, that initially you are going to tell that what is inside the environment, and this thing actually is given to the logical agent, and then he asks that what to do. So it is the task of inference engine to utilize this knowledge and come up to some kind of actions that need to be taken in this particular scenario. And when this inference engine comes up to any kind of conclusion, it tells that do this particular part. And then again, it is the agent's part to execute that action. So execution again is a part of agent, and he would use actuators to actuate to do something into the environment. It is very necessary to understand that this knowledge representation must be into some formal way, so that you can do a kind of general inference engine kind of things on that. So so generally there is some language we use that particular language to define this particular part. Any questions on that? Okay, so this is the generic knowledge base agent. So let me tell you that this is the generic knowledge base agent program, where it is initially gets what percept. So percept means it sees that what is happening over there. Then at a particular time, it sees that what is the percept it has. Then it tells that particular thing, okay, to the uh, to the core part, and using what is the percept at what the particular time and what is the knowledge base. It does some kind of processing, and after that tells that what is the action that you need to take. And then based on that action at that particular time, somehow somebody have to make that, if this action I have to take, what are the right actuators I have to start, what are the right things what I have to do. So those things, those mapping is required, and after that it is going to again tell to those actuators, and then when the actuator is started, then the same action is actually executed. Then the time is advances and we keep moving in this particular way. We come to this particular very important part, that if you want to represent a knowledge, how can you represent a knowledge? Okay, so knowledge representation can be into two ways, and one of them is called the declarative, and another is a procedural. So this is a very important line. Please focus on this. What is declarative and what is declarative and what is procedural? In the declarative one, you define everything. For example, apple is red. For example, apple is red. Okay, if you want to define that apple is red, and so you define in this particular way. So what could be right way to define apple is red? So you define a property red. You define a property red, and you say that red apple means apple is red, and you can say that red is the flower. Okay, similarly you can define green something, and you can say the guava. Okay, cucumber is green. So every information you are coding in some way, and after that if you provide every information in this particular way, it is called what? It is a declarative one. Okay, a declarative one, you are declaring everything. And the approach could be a procedural approach, where you define some procedures, and by this procedure you are going to make that particular thing true. So what do I mean by that? You are actually in the procedural way, you are not actually defining the complete thing. You are writing some way in which by this things are defined. For example, you can write a program code, and using that programming code, something is defined. So it is very similar to the set theory. In the set theory, what you do, either you define that in the set theory that what are the you know that what is set. Set is a collection of well-defined items. So you in the set you define that 2, 3, 4, 5, 6, 7. For example, you define this thing. And another way of defining is this what? That it is x such that x is greater than or equal to 2 and x is less than equal to 7. So this second way of defining thing is a procedural way where you are actually in you have a procedure to define that particular thing. And using this definition also you can understand the same thing. Yes or no? Uh, can anybody please speak so that I get the idea? Look, whatever I'm seeing on my screen, the same thing you are also seeing. Okay, so I'm sorry that I'm not aware what you are writing or anything doing. Is there anyone who can speak?
Yes, sir, it is clear.
Yeah, yeah. So please keep speaking in between. Okay, otherwise I would lost track. So generally what happens now, there is a kind of a chat that comes in front of us, but right now I cannot see that. So okay, so so is it clear? So there are two ways to define the knowledge. One way of defining knowledge is that you are actually declaring everything. But another way is this, that you have a procedure. By this procedure you define something. So procedure you can think of as a program, because ultimately whatever you are writing something, it is going to be translated into a program, and this program actually generate those kind of things. The two way of defining the things. Let me define a very easy kind of thing for you. So let me define that how a complete logical agent can be defined. Okay. So let me define in this way. That let's assume that this is the scenario. This is the space. And in this space, how many places are there? 4 into 4, 16 places are there. Okay. How many places are there? 16 places are there. So okay, 16 places are there. So here we have an agent. Let's assume that this is an agent. I call it a. This is an agent that I have, and the agent is having some kind of arc. So agent can move in any direction. Okay. If there are some, if we in this particular problem, if we define that he cannot move in this particular direction, then restriction, there is a restriction. Otherwise, generally he can move in all the places. And here also there is a restriction. If you can think of for example, he cannot go here because he would be out of the place. He cannot go into this particular direction. So this particular agent can move in two directions. So he can either go here or go here. He cannot go into diagonal way. So in one step he can go into this particular direction. The setting is this, that this particular agent want to find out gold. So there is somewhere gold. Okay, he want to find out that particular gold. Okay, so his task is to find out this particular gold. But this is not a simple place where there are somewhere there are pit. Means if he goes into this particular block, he is actually inside the pit and he cannot come out. Let's assume that he cannot come out. And the setting is this, that if there is a pit, so around the pit, if there is a pit, so around the pit in the all the four places there is some breeze. There is some breeze going on. If there is a pit, so in the four places there is a breeze. For example, you can see here, here is a breeze, here is a breeze, here is a breeze, here is a breeze. So if here is a pit, then these two places are there where there is a breeze. And in this environment, let's assume that there is also a adversary, and for example, vampires. So this can kill this particular person. So in the pit, when he goes, he is alive, but he cannot come out. Similarly, if he step in this particular cell, so this vampires would kill this particular person. So he have to avoid to going into this particular place. This problem statement is clear. So let's assume that this is the game in which you are, and you are a agent, and let's assume that a computer agent is there, and his task is to find out this particular gold. And the setting is this, that if he find out the gold, he get 100 points. If he dies, then if he is killed by this vampires, then -100 is actually gone here. So he get minus 100. Similarly, we can also assume that when he goes inside the pit, he also dies. If whenever he takes a step, he have to spend 1 rupee. So step takes minus 1. He have arrow also, so he have a kind of arrow also, so he can shoot that arrow. If he shoot that arrow, he have to spend 10 rupees, 10 points. And but however, it is assumed that let's assume that he here is a vampus, and when this agent is here and he is throwing the arrow in this particular direction, so definitely this particular vampus would be killed. Let's also assume this particular part, that vampus would be killed. So when the vampus is actually killed, at that time he would be screaming. Okay, he would be screaming. So he would be screaming. So so that he can understand that okay, there was a it was not a misfire. Okay, if let because he don't know, because when he is here he don't know that what is there in inside the nearby things. Please also understand this: when he is here, he did not know that what is nearby area. So if he throws an arrow and he does not say, get any voice of the scream, it means that it arrow is actually lost and Vampus is actually alive. So what kind of sensor is needed? Something who can actually tell him that whether there is a screaming or not. Something that can tell him that where there is a breeze or not, there is a glitter or not. Because if there is a glitter, then he would tell something to pick, and by this he would be able to get the gold. And smell, he have to also have to smell, so that you can find out that whether there is a vampus or not. And I think I forget to mention that if there is similarly in the same way, if there is a pit, so nearby areas there would be a breeze. If there is a vampus, so nearby areas there would be some stench. Okay, so some bad smell is coming because of him. So he also needs something to smell, so that he can find out whether in the next cell there is a vampus or not. So bumps. So bumps is also needed, bump sensors, because what happens now, if he is here, he try to move into this particular direction, so he would be getting a bump. So he knows that okay, no, this is not the right direction to move. So these are the sensors that are actually deployed over here. What a kind of actuators are there that can act into the system? So he can turn left, right, and go forward and grab. Grab is something that actually, if he says grab, so if there is gold, the gold is actually grabbed. Release, he can release the grabbed gold, and similarly he can, as I discussed, that he can shoot. Environment, as we told just now, that is there is a smell around the vampers and breeze around the pit, and this is what the scenario is. Now, very interesting question: that how can you design a system so that so that it can understand that what action I have to take to move to go to this particular direction. Okay. So your task is to make a this agent in such a way so that it can apply some logic, whatever the information is available to him, and he can move freely and get the goal. So let us also discuss something more about the environment. So whether the environment is observable. So means what? Fully observable. Okay, observable means, let's assume that I'm talking about a fully observable. Is it fully observable? Yes or no? Can anybody tell?
No, no, sir.
No, because
No.
he only sees that what is inside this cell. So nearby cells, he don't know that where the things are. Okay.
Yeah.
Is it deterministic?
Yes.
Why? Because things are not changing. Okay. Whatever the things where there is a pit gold and things, if I say that this particular vampus is moving, then it becomes no. I'm sorry. Deterministic means what? That this particular it is a static I was talking about. Okay. Deterministic means what? That when he have a arrow and he shoots that thing, so arrow, it is not like that with a 50% probability this particular vampus is going to be killed. So if he does something, he would be there. For example, into the pit one, if he goes here into this particular cell, he would be inside the pit. It's not like that. He would not be like that. Every action is deterministic. If you want to do that, that thing would be happen. Is it episodic? I think answer is also written. So very less thing to. Hmm.
Sir, excuse me.
Yes, please.
Yeah. What does that episodic mean?
Episodic we have discussed into the earlier classes. It means what? That if you have to do multiple things to do something. if there are multiple things, for example, 5 steps, if there is some instruction given such as kill vampus, if there is such actions, so here he would give this particular action, the kill action. So in the kill action, let's assume that he moves in this particular direction, then do this, then do this, then do this. So if there are few predefined things that this instruction have 5 inherent or 6 inherent or whatever number of inherent individual instruction inside that, then I say that this is an episode, execute this episode.
Okay. Set
So
set
it
of
is,
instructions.
yeah, if inside one instruction, there are some instructions where inside one instruction there are multiple things happening. So it is
Okay.
not like that. Everything is independent. So it's not, there no episode. So if I say that do go in, for example, if I say turn left, turn right, so one thing is going to happen.
Okay.
Okay.
Yeah.
Forward, one step forward only. Grab, one step grab only. So it is not episodic. Is it static? Yes, because I talked about that everything is fixed. So pit is not moving, Vampus is also not moving, gold is also not moving. It may be possible that in a different setting this could also happen. So discrete, yes, everything is discrete. In one cell, whatever is there is there. Okay, so it is not like that. If 50% is here, 50% is there. So everything is fully either inside one cell or other cell. If the pit was here, so in for half is here, half is here. It is not like that. Single agent, yes. How many agents are there? Single agent. Okay, so it may be possible that I can say that it is a big environment where multiple agents are there and they are also moving and something happening. What to do on that? So this becomes very challenging. Make sense? Okay. So let us see that how the Vampus work problem actually works. Okay, if you want to build this particular system. So just to give you an idea, and I think you are also equally you can participate and tell me that if I'm doing anything wrong. Okay, suggest me that the right way to do. Okay. So what I was telling, I was telling that initially the system is actually into this particular, my agent is into this particular place. This place is okay now because it's a starting position. If there has been Vampus can also be into this particular cell, but if the Vampus is there is no point in asking any kind of question because when the game start, he would be killed. Okay, so this place is okay. So if this place is okay, means what? And if he sees that what is the percept he have, so he sees the percepts and he says that there a breeze, is there is a breeze into this particular cell because he have the something to
No.
measure. Okay, no
Yes.
breeze. Is there a stench? No.
No.
So if there is no breeze, means what? There is no pit. Pit is not here. No pit.
Yeah.
No pit here. And Vampus is also not here. Vampus is also not here. He knows that. It means that it is safe to go into this particular direction. So if he knows this, he can move in any direction because these either he can go here or he can go here also. But when he goes here, he find bumps. Then he updates his information that okay, no, I would not next time not go from this particular place to into this direction. So he moves into this particular direction. He comes here, then he sees that okay, it looks like that there is a breeze. There is a breeze. So because there is a breeze, so there is a possibility ki it may be possible that pit could be here or pit could be here because it's a breeze. If there is a breeze, you
Yes.
can see that here breeze. So he don't know na. So pit could be here also. Pit could be here also. So he take this step? No, he cannot take this particular step. Similarly, can he take this step? No. So what should be the action taken by this particular agent? He
Go
must
back.
come back.
Go back. Yeah.
Okay. So here next item is that he goes here. He find out the stench. He found out the stench over here. So it means what? Looks like that if there is a stench, it means that it may be possible the Vampus is here or Vampus is here because stench is here. But when he was here, he has seen that there are no stench at this particular place. There is no stench at this particular place. Means what? Means what? That if Vampus has been here, then stench maybe it must have been here. So it means that Vampus is not here. Okay, this is the logic. Okay, I am applying this particular logic from here because of stench. He sees that possibility of Vampus is here and here. But when he was here, he had discovered that this particular when he was here he had discovered that there are no stings, so he says that Vampus is not here. And similarly, when he is here, he sees that stench is there, but no breeze is there. It means that pit is also not there. Do you understand? And by applying this particular logic, he can now, he says, he can understand that okay, looks like that this place is now safe. Okay, so from this particular position he goes this particular position. Okay, from this particular position he goes to this particular position. And but you can also say that when he have actually understood that Vampus is not here and Stinch is there, it means that Vampus is here. He had actually located that Vampus. So what he should do?
Kill. Shoot.
Kill.
Kill that, no?
He can kill it. But actually this is not his task. This is not his task. If he kills him, so he is going to spend some money. How much it was? I think 10 rupees. Okay, he have to spend 10 rupees. Unnecessary killing this Vampus means nothing, na? So he would not kill. He would go into this
No,
particular.
but if he kills it, he can move in the direction, no? And he is safe in the next future attempts.
Yeah, if it is required, then he must have to do. Okay, if but right
Yeah.
now it is not
Yeah.
required. Okay, so he would
Yeah,
move
there
into
are
this.
other ways.
He would move into this particular place.
Okay.
So he would not kill right now, because if he kills, then it is a unnecessary step. Right now he is going to spend some money, because it is not like that he is forced only this to go into this particular direction. From here he sees that there is now he knows that there is nothing like this, so he can go into both direction, this direction, in both the directions. But if he goes here, he sees again breeze. You can see that here is a breeze, so he can come back, and then he only way to go into this particular direction is this. When he reaches here, he sees that there is a glitter also. So there is a glitter also. So when he sees the
Collect the
glitter,
gold. Yeah.
so he says that pick or whatever action was there, grab. Okay, he says
Grab.
that grab, and by this he would be able to get that. So you can see that this is not a very new thing. It is a small game that many of the time you may have played. So this is how actually this you can apply the logic, and the Vampus, this particular agent, can find out the path to discover all these things. Okay, so you understand that how you can do the inferences. So let me give you the idea that how to represent this particular things, and then how to do the logic on that. So our task would be that how this particular all these information can be systematically applied, systematically represented, and how the logic can be applied on this to find out some kind of inferences that can help us to guide. Okay, uh, so as I told you that there are sentences. Sentences is now a technical word. Okay, what is a sentence? Sentence represent knowledge. Okay, and they are written based on some syntax. So we define some syntax, and this syntax actually tells that how to write the things, and whatever we are going to write, they are into the some well-found way, and this well-found way is called sentences. Okay, when we have a sentence, so a sentence can be true or false. Okay, because when we provide any kind of information to you, for example, if I say, so the basic point is this, that if I say that, for example, I say the red apple. Okay, so you say that it is correct. This is information if I provide you. So red apple is okay. But if I say that red cucumber, I have never eaten it. So, okay. So if I say that red cucumber, so this is false. Okay. So if this information, if I provide red cucumber, then it becomes an information for you. Then you say that, okay, cucumber is also red. But if I ask you that whether red cucumber, you say that false. Make sense? So this is an important part, that if you have a sentence, so if it is given as a knowledge base, all the things are correct. But when you come up, you deduce any of the new things, then for that you can assign that what is the truthness of that particular thing. Okay, for example, if I say that x plus y is equal to 4. Okay, so if I say that x plus y is equal to 4, so it is a model. It is a model that I'm telling that x plus y is equal to 4. And now I can assign the values. Okay, so this is a very interesting thing. Okay, let me tell you. So what I wanted to tell, that if I say that x plus y is equal to 4, x plus y is equal to 4, so it is a model. So it is again just see that this is a different way of representing the thing. X plus y is equal to 4, it means what? X is equal to 0 and y is equal to 4. X is equal to 1 and y is equal to 3. X is equal to 2 and y is equal to 2. x is equal to 3 and y is equal to 1, x is equal to how much? 4 and y is equal to 0, x is equal to 5 and y is equal to -1. So these set up the things. This particular sentence actually represent these many informations. Able to make sense or not?
Yes, sir.
So this
Yeah.
particular line, this particular one thing is actually a kind of representation that I was talking about, that this is how you encode the things. So either you specify all these things when x is equal to 0, y is equal to 5, this is like this, or you use this thing to define the same thing in a better way. So, if you say that x is equal to 1 and y is equal to 3, then it is fine, because if you this is your model, then it is true. But if I say that x is equal to 2 and y is equal to 3, no, this is wrong thing, because this is what the inside my information. Okay, this is in my knowledge. So very interesting thing. So this is the model, and if you have a model, for example, this is a model. So you can say that alpha. So here you can tell that something is being represented by this. Okay. So this M alpha means what? M alpha represent all those things that we have just talked about. So okay. So why what I told you that this is model, this is model F, and what is M alpha? M alpha is the things which are actually entailed in this particular knowledge. Okay, so they are coming from this particular knowledge. So very interesting idea. There is also interesting idea that sometime what happens now, from one knowledge you can, as I'm telling that, you can extract something else. So if you extract, you combine those things and find out something interesting, then you say that alpha has derived beta. And if alpha has derived beta, so it could be more general, means it has more things into the system, and out of this alpha is actually a small part, because you have used multiple things to derive to beta. So from alpha, if you derive beta, so beta, the things which are there inside the beta, they are more as compared to the alpha. So this diagram is very interesting, and you must understand this particular part. Here there is a line, okay, and let me tell you, this diagram is actually very important to understand and very easy to understand. Okay, all of you have the intuition of this. I'm just wasting your time. So what is this? That this is the word, real word. Okay, real word things are there. So if I define any sentence or any kind of things, any kind of model, any kind of knowledge, if I define any kind of knowledge, so it has some meaning into the word. That in the word, what is something like that. For example, if I say that x plus 1 is equal to 5, or 2 plus 2 is equal to 4. So in the word happens something, if there are two elephants and two more elephant comes, it becomes four elephants. So there is some semantic informations attached with that. Am I able to make sense? Otherwise, you cannot represent anything as a knowledge. Okay, you cannot find out the representation. And representation could be many. You can think that in the different way we can represent. Who was telling that use only 1, 2, 3, 4? So in the Hindi, you know that 1 is like this, 2 I think 2 is like this, 3 is how much, 3 is like this. So these are the different symbol as compared to the one. So I. So these are the different kind of symbols, but they represent the same thing. So in the representation word, you are going to represent to the word. Okay, it is a maybe mathematical convenience or any kind of deduction based things becomes easy. That's why we go for any kind of representations. They have meaning. This is a very important part. Yes or no? So you cannot generally have any absurd kind of things into your representation. So if you have any kind of knowledge, the point is this, that if you any kind of sentences that you have, and you do something and come up with new kind of sentences over there, they also have some meaning into the real world. Does it make sense?
Yes, sir.
Does it make है ना?
Yeah.
Because if you have something, so right now let's forget about this particular part. Just think, because we are into the representation way, we are here. Something is given to me as a knowledge. So we understand that there is some aspect of word that is associated with this. And now if we can derive something new, it would also have some kind of aspect over here. And if we go into the real world, so in the real world, using this other information can also be derived on that. So this is what the basic thing, and it's not like very difficult. So you can see that this is a requirement of the things. Okay. So let us talk about something about the propositional logic, and this is the systematic way to represent the to do a kind of logical to logic into our system. So propositional logic actually says that there are some proposition, and proposition are actually declarative sentences which can be true or false. So using those kind of sentences, we can represent something. So for example, here few are the sentences which are provided. Can you tell me that which are actually propositions or which are not, which are means which are the sentences which can be assigned the true or false value? So proposition are the sentences which are the things which are actually that can be assigned true or false value. So only those things are actually right knowledge. If you want to provide me a knowledge, so it this particular sentence must be assigned true or false label. For example, sum of 5 and 4 is 9. So you know that this is true statement. If I say that sum of 5 and 14 is 9, I can also write like this. It is also a proposition. Okay, if it is a proposition or declarative sentence, it is also a proposition. At that time, it is false. Okay.
Yes.
Next statement. Could you give me pen? This is not a declarative sentence. I cannot assign the true or false on that because I'm asking somebody. Next question. Every even natural number greater than 2 can be written as a sum of two primes. So this is what? Again, it is a difficult thing to know. So this example is very specific. For example, if I say that every even natural number, so for example, 6 can be written at the sum of the two prime numbers. What are those prime numbers? Can you give me? 5 and
2, 3. 1 to 3.
2 and 3
and
to
5.
5.
1
1
and
and
5.
3.
1 and 5. Okay. So every natural number can be greater than 2 can be written as sum of two prime numbers. So this is a very famous thing. So do you know that this statement is true or false?
It checks.
Yes. True only, no? Yeah, it's proposition only, no?
It is proposition because you can assign true or false to this particular sentence. Okay, whether you know true or false is not required. So this is why I put this thing that whether this statement is true or false, it is not required. Okay, means you know whether what is the truthness of this thing, it is not required, but you can assign true or false. And let me tell you that if you can assign true and false, now please let me know. Okay, it's a very interesting problem, and you would be getting $1 million if you can solve this particular problem. Okay. So many such problems are there. We don't know that whether they are true or false, but it looks like that they are very simple and looks like that it is true. Forget about that. For example, next statement is best of luck. Can you assign true or false? No,
No.
no. So this is also not a proposition. So in the propositional logic system, we can say that this is a statement. Now I can give a name P1. I can give this also name P2. There are two statements that I have P1 and P2. Or we can write P and Q also. It may be also possible. I can write this is the statement number P. This is by Q. I say that this. Okay. So I can give name to them. That is a also a very good idea. So, for example, sometime it is better to assign symbols to atomic sentences. As I told you that when they are atomic sentences, I can assign the P. For example, P is I won a lottery ticket last week. Q, I have purchased a lottery ticket last week. So you can see that Q implies P. Okay, because he have purchased, then he has won this particular thing. So all those things will come later. So actually this is the slide that actually trying to tell that if you come up with a kind of if you come up with a kind of sentences, then you can say that P. If you P means what? I won a lottery ticket last week. Or P means what? Here we have written sum of 5 and 4 in 9. Let's assume that I say this. Okay, P is this statement. Sum of P and 4 and 5 is 9. I can say that not of P. Not of P means sum of sum of 5 and 4 is 9. No, 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 no. Sum of 5 and 4 is 9 is not true. Is not 9, that would change the things. Okay, we must say that when we apply a not, we said that the statement that sum of 5 and 4 is 9 is not true. Okay. Similarly here. So you now you understand that what is not. Similarly, in the same way, disjunction. So that conjunction and disjunction, that P R Q. P means I have a car. Q means I have a helicopter. P R Q means what? Either I have a car or helicopter. Am I writing correct? Let's assume
Yeah.
that
Or yeah.
I have car. I don't have helicopter. Okay. Similarly, P and Q means I have car and helicopter. So this statement is false. Okay.
Mhm.
Implication you understand. If Q implies P was here, he have purchased a lottery ticket and then after that he have won something. But into the logical domain, now what happens that they are actually very formal way to write the things, and this table actually gives you more understanding on this. And I'm pretty sure that all of you actually know this. I'm just wasting your time once again. So tell me that if I can go forward. Okay, all of you know this, that if P and Q are there, so not P is the negation of P,
Course.
and there is a truth table. So and becomes, how you define and? It is true when both of them are true. This is defined in this way. So it is both of them are true, then it is true. How R is defined? It is false
One
when
of
both of them are false. Defined into this particular way. P implies Q is an important statement. That if I say that P implies Q, so P implies Q actually says that it is false. It is defined in this way. False when P is true and Q is not true. Q is false. In that case, it is false. Otherwise, everywhere it is true. So that is the only reason. Sometimes people say that it is, this is, since it is a false, so it is a negation of P and minus Q. And this you can say that minus P or minus Q, that becomes Q. So this is equivalent to, if I say that P implies Q, so it is same as minus of P or Q. Is it right or not? Okay. Similarly, there is a something called the double negation that says that if P implies Q and Q implies P, then I can say, I can write that P double Q. So this is the truth table thing. And any questions on that? Please let me know that and tell me that you are comfortable with this. Yes.
clear.
Yeah. So there is a very important thing that is called the natural deduction that tells that suppose we have formulas. So these formulas are sentences are the same thing. I say that. So let's assume 1, 2, 3, 4 n formulas we have, and using m formula, if we come up anything new, that is, let me tell psi. So this is called the sequent, where I'm telling that I'm going to deduct devise a new thing on that. And if there is a valid proof found, could be found, that using this, how can I deducted this, then I can say that this is also entailed into there. It is there inside my knowledge base. That whether this makes sense to you. So multiple these things, you can see that P, Q, R, S, multiple things are there, and based on this you find out, somehow you find out some proof, and by this you say that this is also a new thing that I have obtained. Okay, so let us go some do some kind of understanding on mathematical part. So this is something and that I wanted to tell to you, that if it is just maybe revision for some of you. So what it is, if I say that I have I I'm very sorry. Huh. So if I say that there is phi, there is something called phi and there is something called psi. Just give me time class. Yeah. So if you two things you have, if you have phi and psi, you can say that I have phi and psi. Any problem in that? Yes or no? If you have phi and psi, you can say that I have both phi and psi. Is it fine?
Yes.
Yes.
If I have phi and psi both, I can say that I have phi because I have both. Similarly, I can say that I have psi. So this is called the and introduction. And introduction. and elimination 1 and elimination 2. Elimination 1 means the first thing I have taken, other is eliminated. Elimination 2 is this, I have removed this. So now I have a small question. Let me do it. So let's assume that I have P and Q and I have R. So can you tell me that I can derive that I have Q and R? I can derive this thing on this. Can I derive this? Okay, let me show you that how you can do that. So so the idea is this, that you write that I have P. 1 minute. You write that I have P and Q. So if you have P and Q, you can say that you have P and you have Q. Yes, using this thing and this thing. And R
Yes.
is also given to you. So you have R. So since you have Q and R both you have, so you can write that you have Q and R using this thing in this thing. So this is the way to derive it. Very simple,
Yeah.
convenient. Yeah. So we are going to
Yes.
see more example on that. So I give you example to solve by yourself. Show this, that P and Q and R and S and T. Then can you show me that Q and S I have? Yes or no?
NQ.
So S and T are there. Now you can take S from here. Q, P, Q, R is there. So you take P and Q I have, then I have Q. So Q and S I you have, then you can write like this using this particular method. Yes or no?
Yes, sir.
Sir,
Yeah.
what is S there?
What is S? Please ask. Please ask. Please ask. What was the question? I'm not able to hear you.
Sir,
Yes.
that after S and Q, S and T, what is
Uh,
that symbol?
This
What?
symbol. This is a deduction
Yeah.
symbol. Nah? From these things I get this thing. This is
Oh, okay, okay.
this till that from these things I'm going to get this. Okay. So I was telling this now here. I think this was the thing, that if I all these things we have and from this I get this.
Okay.
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 Yeah. Yeah. So it's same way. If I have phi, I can say that not phi. If I have not phi, I can say phi. If
True. Then,
it is
yeah.
a double negation removal.
Double
So
negation.
if
Yeah.
so can you show me this thing? Can you show me this? Again, all these things are very simple. Okay. I'm just wasting your time. So what I'm telling that I have P. Okay. I have not of Q and R. It means that I have Q and R. Okay.
Yes.
So it means that I have Q. It means that I
R.
have R.
Have
Or
R.
since I have P, I can say that I have not of P. So I can combine these things. I can say that R and not of P. Or I can say that not of P and R. Okay. ये हटाओ यहाँ से. Okay. Done.
Yes.
Great. So we are doing fairly good. Okay. So this is how we can show it, and you please note that how to write this. Okay. Every sentence you are going to explain that why it is coming. Premise means it is given. Okay. Then how I got this on the line number 1 I have applied this, and line number 4 I have applied it. Please by yourself do it on your rough work. Okay.
Sir,
Yeah.
not of P is equal to P, right?
Yes. Yes. Yeah. It is written na phi is not phi. Not phi is phi. Okay. Next condition is this: if you have phi and you have statement that phi implies psi, then you can say psi. That's called the elimination. Okay. So let me see an example. So again, let me write like this. So can you show me this? Okay. So I have what I have. I have premise P. I have P implies Q. So by I have P implies Q. You have to write this. Okay. By combining these things, I get Q. I also have P implies Q implies R. Since I have P here, so I can write Q implies R. Okay. Since I got the Q from here, I can say that I have R. Okay. So infer R. So I have actually inferred that I have R. Infer R key R I can write like this. Okay. So you got the R? Yes or no? Very simple. So there is a very interesting idea that if phi implies psi and minus phi is there, it means that minus phi is there. If negation of this particular item is there, then definitely negation of this item is there. That's why it's possible. So it is not possible. If the negation of this is happened, it means that negation of this is happened. This is called this statement has a name called modus tollens, and we can also utilize something. So here is an idea that in the same way you can get if minus of phi is minus of psi is here, then you can say that minus of phi, you can infer something like that. So here is again a question that can you show me that P implies Q implies R and P and not R implies not Q. So can you show me? So I leave it to you. It's not very difficult. Next thing is important actually. And this is actually that how do you make this thing that phi implies psi? So there is a very interesting idea that actually tells that that actually tells this that that if if you have something phi and you are doing I don't know what, but after that you reach to psi and inside this you are inside a box. So please note that making box is very important. Then you can say that phi implies psi. Once again. So if let's assume that there are few information available to you, and here inside you assume something. Let's I assume that phi is the or you have something available, or you by yourself assume something, and by doing thing you come up with something. So you can say that theta implies phi. So this is how you introduce it. You create it. Let me give you an example. So it would be more clear to you. So this is what it is. So if I say that, can you make this thing? So I'm asking that, can you make this particular thing? Okay. How to do that? Okay. So here if you closely analyze, so you can see that there is this particular thing is applied. Okay. And after that, there are two parts. So essentially, if there is Q implies R and you do something at the end, you reach where minus of Q implies minus of P implies R. If you reach to this particular thing, then what you can write? You can write that Q implies R implies what? Minus of Q implies minus of P. Look, I'm telling the things which are very simple. Okay. Please interrupt me if there is any issue with you. If you are not able to follow anything, it's very easy. So is what else? What easy I can do? So here this is a statement that tells that if there is something phi, it goes to psi. So you can write like this. So using this thing, I have written this. Any problem on that? Yes or no? And as I told you, the first statement can be assumption. Nobody is telling yes. Nobody is telling yes. Is there anyone who can tell yes?
Yeah, it's clear.
Look, just see this part that I have written something here, then I can write this statement. This is fine. Whatever is being written, I don't want to go inside this. This is fine. Now, if I want to write, because here also there is an implication statement. If I want to write something, so there should be some bracket where I start by not of Q implies not of P, and then I reach P implies R. If I reach into this particular scenario, then I can write this statement. So inside bracket, let me tell you once again, inside, if this bracket is very important, this bracketization is very important. Inside this bracket, first statement you can assume. You can assume by yourself. So it is a new word where I have this assumption. And by this assumption, this something happens, so I can write anything. This is a very important part. All right, so this I have to go like this, and in this again you can see that since there is again a implication statement, I can write something like this. I can say that if there is P and somehow I reaches to R, if this is my assumption, so I can write P implies R. Okay, I can write P implies R. Now in between I cannot do anything. So is there any way to connect these dots? So at this particular place, at this particular place, at this particular place, you have P or all these things are available to you. Okay. So if P is available to you and not P implies not Q is available to you, it means that what? That not of Q is available to you. Yes or no? Hmm? No. We have talked about now very recently we talked about that in this model tolerance, that if not of something is available, then not of this particular part is this particular part is also available. So in our case, what is going to happen in our case, P is available, that and it's P is actually what, not of P is available. So it is not of P, not of P is available. So if this is available, not P is available, and the same thing is here and here. So negation of this particular item is there. So negation of Q is here, and this becomes what, Q. When Q is there, then you have R. It means that you have Q is available. When Q is available, you have R is available. So all these dots are now connected. So if R is connected, I can write this.
Yes.
I can write this. I can write this. Everything is, proof is complete. So this kind of understanding is needed. So to write all these statements, okay. So in the same way I was actually writing that initially you say that this part, then this part, then this part, then this part, and by this applying this assumptions you can write like this. So I have few questions for you for just for practice. Try to solve these things to by yourself. And then there is something called grammar that is very important, because you want to, whenever you want to write something in a right way, you must have some kind of structure that can take you forward. So grammar is very important, and it is called GRAMMER. My writing is very good. How many of you can tell, sir, your writing is good?
Good, sir.
I think everyone.
Hello. So I say that S implies, let's assume that S implies A and C. Let me write like this. A implies, A is atomic sentence. It can be either true or false or P or Q. These are P, Q, R, S. Complex sentence. So sentence could be atomic sentence or a complex sentence. Atomic sentence could be true, false, or P, Q, R, S, something in one statement, one line only. Complex sentences are if there is a bracket and inside the sentence is there, or the complete only sentence is written there. Two different kind of things are there. Or I think R is also here. Not of sentence can also be written. Sentence and sentence can be written. Sentence or sentence could be written. Sentence implies sentence could be written. Sentence double implies sentence can be written. And then we have some operator procedures when it is required. So these are the operator. When multiple operators are there, I say that this has a higher precedence. Okay. So why I'm telling this? I'm telling this. Can you write P and Q R R? If I ask you that, can you write like this? If this is the grammar, can you create this statement? Is this a right word? If I ask that, is it a right word? Is it a well-formed formula? It is a right formula. Is it a right sentence? My question is it a right sentence? So you can say yes or no, but I would ask for the proof. So you can write, sir, I take S. Then I say that there S is goes to what? S goes to this sentence that I say that S goes to S and R and S. Okay, and from this, since sentence it can go to the sentence could be complex sentence, so I say that S go to C, and then the complex sentence goes to bracket, and inside complex sentence go to bracket, two brackets, and inside there is some sentence. And once again, क्या मेरे पास है? Do I have the space? And this sentence can again take this. This sentence can again take this and complex. This sentence can again be complex, and the complex sentence has the sentence and sentence and sentence. Then sentence can be atomic sentence, and atomic sentence can be P, and this could be atomic sentence. Atomic sentence can be Q. From here, R can be atomic sentence, and atomic sentence if it is R, I can write like this. So I have created a table, sorry, tree, where comma, then P, then and, then Q, then sorry, comma, bracket, and then R and R. So by this I say that this P and Q, this R. I have created this. So if I can draw a tree using this grammar, so you may have studied this in TOC course, your theory of computation course. So this is how you can say that this is a well-formed formula, the correct formula. But if I say something like this, that P, Q, and R, is it a right formula? Is it a right formula? Yes or no?
No.
No, it is not possible. Using this kind of grammar, you cannot create this. Okay, so for every knowledge representation, we must say that we were talking about now that in the very beginning we were talking about this, that when we want to say something, we have to write sentences. So this was the sentence, but sentence come from where? Grammar. Derived from knowledge representation, language or grammar. They are coming from the language or grammar. Okay, so this is how you define the language or grammar, and using them you can now create the sentences. So hope it is clear to you what are sentences and what is the grammar. Grammar is this complete definition which actually says that if you want to farm something, how you actually farm. So I think we were here, yeah. So this is how you actually farm. Any questions on that? So my question is that if I give a syntax in this particular way, so can you find out that some of them which are, if I give you example as I give it just now, so can this be formed or not? Can this be formed? Is it a true thing or false thing? So you can, I think you can tell that yes or no. Yes or no? You
Yes,
can
sir.
create which is right, which is not right. So
Yeah.
if you want to build a logical agent, you define this kind of grammar, and based on this grammar, you only write that what to be written on that. Okay, rule of disjunction. So if you have phi, then you can tell I have phi or psi. It is very counterintuitive and interesting thing. Okay. For example, I have chocolate. Okay. I have, I think car is better example. Okay. If I say that I have, this is car. So phi means what? Car is true. Okay. Means I have car. Okay. I have car. But and let's psi being aeroplane. Real aeroplane. Okay. So if I say that I have car R, this is R, not ant, or aeroplane. Am I right or not?
Yes.
Okay, I can say. Yeah, yes.
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 So this is the importance of the disjunction, that if you have anything, so from out of blue you can bring something and write that I have this thing also. Okay. Similarly, here what was happening, that item was here and you have added something into this particular side. So item was here. If you can also add to the left side. Here you have added to the right side, left side, any side you want to it. You can add to that. However, elimination is not that easy. If you want to say that I have this, and you want to find out something is deduction out of this, that's not easy. So for both of the things, that thing should come. Okay. So if this derives X and this second part also derived X, then only that part you can take. If it is not like that, if this derives something, then you cannot take the X. Once again, what I wanted to tell, that if there is one statement and you do something using something and you come up with the X. So you cannot conclude X using this based on this particular statement until the second part also does something and produces the same X. If both of them produces the same thing, then only its truthfulness is actually validated. Then only you can tell that X has been obtained. So disjunction is really a different kind of game. When
Sir,
you want to when
sir,
you
just
want
one question there. Uh, Phi or psi is given, no? So from what you are explained, it should be phi and psi, right?
no phi or psi. If I say that I have I have aeroplane or car. Okay, I say that I have aeroplane or car, so this becomes true, but I don't have aeroplane. So if I start saying that I can go to Delhi in just 10 minutes. Okay, so using phi you cannot show this is, but psi you can show that you can go to the Delhi in 10 minutes or 2 hours. Let's assume. Okay, for using psi you can show this. But if it is not possible with the phi, then you cannot take this X that you can go to the Delhi into the X. If I believe on you, this statement that you have car or you have aeroplane, and you say that using aeroplane I can reach in 10 minutes, it means that I can reach in 10 minutes. No. By car also, if you can reach in 10 minutes, then only I can believe on your statement. Or somebody tells that no, only this statement that you have aeroplane. But the statement that I have car or aeroplane, then I cannot deduct that in 10 minutes I would be able to, or in this much time, in 2 hours I would be able to reach to Bangalore. Am I right or not?
Sir, one question here. So it could have been true if it was and, right? I have car
Yes.
and
Yeah.
plane.
Then only one thing is fine. Then
Okay.
only if I show this particular part is fine. But if it is R and the statement is this, if somebody has given that you have phi only, means you have aeroplane, and I say that I have aeroplane that I can reach there, it's fine. But if somebody says that phi or psi, I have car or aeroplane, and then if I deduct using the second one that I can reach in the Bangalore in 10 minutes, in 2 hours, I cannot say that I can reach there until the until using car also I would also be reached this particular place. Okay, now this is the
Sir,
important change. Yeah.
actually, phi and psi, if you say, then what you have told would be true, no? And when you put an and symbol, then both should satisfy. But when you are telling R,
I,
one
I,
way it will be possible in one and it will not be possible in other thing, no?
but
This
I'm
or
telling,
this.
just come here. I'm telling R. So either I have this or this. So if I don't have this, and using this logic, I say that I can reach over 10 minutes, 2 hours, then it's not the correct thing.
Acha.
So
Okay.
it's not the correct
This
thing
or
because
this.
it's
That,
R.
you can
This is the
use
problem.
this or this.
So I only say that only those things could be deducted which can be done with the both.
Acha, then what about if I put the symbol instead of R and
Hmm.
suppose,
Ah,
then
ah.
how would the situation? Xi and phi. Then
It is true then.
If you are putting and, so you have both the things. So in the and
then
you know
how?
that no in the and we have seen na let me go back. Okay, Control L. So if we go back, so if A and B I have, I think if A and B I have, I can say phi. If phi and psi I have, I can say psi means I have car, I have aeroplane. So using this psi, I can tell that I can reach over there. Okay, if phi and psi is there, I can take the psi. Here I have taken the psi. Now using psi, I can tell that I can reach over there. But using phi and psi, I'm telling. So it's a two-way process. By this, I can tell that I can reach over there. But if I say that I have R, so with the R, I cannot detect this. From phi R psi, I cannot tell that I have psi. This detection is not possible. Okay.
Yeah.
Okay.
So, okay, great. So where we were. So this is the question. Okay. Can you derive this? PRQ is equal to QRP.
Yes, sir. It is possible.
Looks like useless thing because PRQ it's just a commutative thing I want going to prove, but it's very important thing to show. So if I have PRQ, so how can I say that QRP? Can I say that I have P? No, I cannot say this.
No, we cannot say.
But I can say this says that I can create two boxes where in one side there is phi, another side there is one side there is phi, another side there is psi. So I can create two boxes side by side. Here I can create two boxes. I can say that there is I have P and I have Q. I can say that and do independent logic into this and come up with something so that I can say that Q R P. So if both of them give me QRP, then I can say that I can write like this. Yes or no?
Yes.
So if I have P, can I say that QRP? Do I need to do anything here? Answer is no, because if you have phi, you can say that phi R psi. If you have psi, then you can say that phi R psi. So this is nothing is required here. So by this logic, you can take it forward. You can say that this I can directly write. Am I right or not? And then since it has been deducted in both of them, then I can utilize this thing to take it forward. Interesting. Okay, so there is another question. Please try to solve this. That how can you show that P implies R is equal to PRQ implies QRR. Okay, try to see that. So again, it's very simple. Create two things, one side P, one side R. Try to create this thing and then this thing and see that how you can do that. Okay, it's very easy. I just give this you as a homework. Okay, so this is a very interesting thing that actually says that the rules of negation. Okay, so if there is tautology means something, not tautology is a contradiction. I'm sorry. If there is a contradiction, so you can assume anything. If somebody says that दिन में रात हुई, then दिन में रात थी, रात में मेरा हाथ धूप से जल गया. So if somebody has given contradictory statements, so means now everything, and I assume that both of them are right. Somehow in the deduction I find out that both the statements are there. Please note, if in the deduction, because the information is given in such a way so that both the things can be derived, P and not P both can be derived. It means that it's a false statement, false word. So now you can assume anything. So I can assume phi, whatever be. Are you able to understand? Yes or no? If I say that uh, in the night, in the in the night, धूप से मेरा हाथ जल गया, तो इसका मतलब नाइट में धूप था. So what does it mean? That is contradiction. In the word I am living, I can do anything. So elephant were flying. I can assume anything. In the same way, this is this is that how it happens that if phi is there and not phi is also there, then I say that it is a contradiction. And when there is a contradiction, you can assume anything. Phi, if there is some statement that leads to actually contradiction, general चीज ये है, देखो general चीज क्या है? If you have any statement phi and it leads to contradiction, it means what? ये assumption गलत था, means this is not a right assumption. Minus phi is correct. Is it that, does it make sense? Does it make better sense? Does it make better sense? If you have something and you did something, some logic, and after that you read to a contradiction, means what? That this assumption was wrong. Hai
Yes.
Okay,
Yes.
this assumption
Yes.
was wrong. So this is the right way to prove. However, in the scenarios, if you have any kind of contradiction, then you can assume anything, because if it is coming from your system that there is a contradiction, then you are into the false word. So we are not going to talk about this. So this, can you show this to me? Minus of P R Q is equal to P implies Q. Okay. So let me show you that how you can do this. Control V. So so you know that when there is an R, you have to write that you can write two boxes, and you can tell, because this is given to you. So you can create two boxes, and two boxes, one box you write minus of P, another box of Q, and you keep doing something so that at the end in the both the places, if you get P implies Q, and here also if you get P implies Q, so you can say what? P implies Q. So this is what the framework we have. So with the minus P, what you can do? So very standard kind of thing. If I say that I am going to assume something, and assume, because if you want to P implies Q, then what you have to assume? You have to start from P and reach to the Q, then only you can write P implies Q. Here also, if you assume P and you reach to the Q, then only you can write this. Okay. So this was premise. This was given to you, and this was your assumption. So P is there, minus P is there. You can see this at this particular point. P is also there. Q minus P is also there. It means what? It is a contradiction. If there is a contradiction, you can assume anything. So I have assumed Q. So I can write P implies Q. Am I right? If P is there, Q is there, I can write like this. Let me go to the second part. There is a Q. Inside there is a P, and Q was here, so I can copy is here. This here I'll become P. Q is available. So if P is here, Q is here, I can write this, because outside this box P implies Q is there. And therefore, since both of them are going to give me P implies Q, the P implies Q is here. So a simple kind of logical inference is needed, nothing more than that. Okay. So there is one more question. Try to solve this from your side. Okay. For example, alpha and beta is equal to beta and alpha r beta is equal to beta r alpha, and there is a commutativity also, alpha and beta, and then you can take it like this, alpha r beta. So this is minus is alpha, is it is a double negation elimination. A implies B is minus minus of B implies minus of B implies minus of A, and this particular A implies B is equal to minus of B implies minus of A, and this is contraposition. This is called the contraposition. A implies B is equal to not of alpha r beta, double implication. You know that what they mean. Not if you apply, it goes inside. This is called the De Morgan's law. So it goes minus of alpha minus of beta r. So hope you know all these things. Should I explain anything? And this is if the R and both are there. So the distribution law we can apply. We can say that alpha goes inside here, alpha goes inside here also, and then in between there is R. And in the same way, if I reverse this, so the same way the distribution. Okay. Any questions on this? Fine. Please tell me. Please tell me it is fine.
Yes, sir. Yes, sir. Fine.
Yes, it's fine.
Okay. Now I wanted to tell you two very important concept that is called as soundness and completeness. Does anybody know this? बताओ मुझे. What is sound and what is complete? Please attempt. What is soundness and what is completeness? So soundness means doing right thing. So let me give an example. And for example, let's assume that I have a box. I have a box and there are 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 red balls and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So how many things are there? 25 balls are there. In this particular box, 25 balls are there. If I ask somebody that give me give me all the red balls. Okay. Give me all the red balls. If I ask from somebody that give me all the red balls and he gives me give me all the red ball and he give me 1, 2 तो गलत हो गया and he gives me 1, 2, 3, 4, 5, 6, 7. He gives me 7 balls. Okay. So he is sound. There is one person who has given me these 7 balls. All of them are red. So he is sound. Let's assume that there is some confusion in the balls. The balls have some color, so it requires something to do. There was another person who has given me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12, 13, 14. He has given me 14 balls. This particular person has given me all the red balls along with this is the wrong thing that he have also done, but he have full coverage. Okay, then we say that he is complete because he had done the complete thing. Nah, he had given me the complete thing. So it is complete. The second person, if I say that this is the first person, this is the second person, A is sound, A is sound, B is complete. Complete does what? That it gives complete all the things, but maybe possible that extra he can do. So it is not like that in every time he is going to do that. If both the things are there, sound or complete. If both the things are there, then this would not be there because sound means what? That he's not going to do anything right or wrong. Complete means he's giving me complete thing. So we want soundness and completeness. Both are only one. What we want?
Both.
Are you clear?
Both.
That yeah. What is sound and complete? This thing is clear to you.
Yes.
So these are the two systems. So I have two legal systems. One legal system actually assumes one legal system actually assumes guilty until proven innocent. Let's assume that there is a legal system which actually tells guilty until proven innocent. So this system is what? Sound or complete? It assumes that everybody is guilty until proven innocent. So all the guilty people, if somebody has done wrong thing, he would be definitely caught. Okay, who can go out? Who can be released from the jail? The people who are innocent, and
Yeah.
if there is a proof that they are innocent, so he catches every problem, particular person who has a problem. Am I right?
Yes.
So it is complete or sound?
Complete.
It's complete.
Sound.
Complete, na? Because he catches everybody. Leaves only those people who have somehow proven that no, I have not done this. Okay. And next legal system which tells a innocent until guilty. Everybody is moving outside. If somebody has proven guilty and means then he would be put to the jail. So who goes into the jail? Who is proven guilty means rightly we know that he has done something wrong.
Guilty.
Right? So only he does right thing. This system does the only right kind of people goes into the jail. So is it complete or sound?
Sound.
Sound, because people
Sound.
who have done the bad thing, we are able to prove they would go inside. So go to the jail. Okay. People who have done the wrong thing, but we are not able to prove they would be roaming outside. Better system would be which is complete and sound both. How to make that? So think about that. So this is an interesting example. So in the same way, I can ask some questions that can you tell me that whether it is a sound or complete? Then we have to do something. So a few minutes back, we have talked about that using sentences, we can write complex sentences, and in simple literals can be applied negative and or implication, etc. So there are some standard ways also that actually tells that if you want to represent it is a better representation because of some obvious reasons that it is easy to find out that what is correct or what is not correct. So in that particular pursuit, because ultimately we have to apply logic. So the things which actually facilitate applying logic into easy way, that is a better way. So one such representation is a conjective normal form. So what is a conjective normal form? So there is a conjunction, na? And inside there are brackets, and in so there are if I write something like this, that there are disjunctions here, and outside there is conjunction. Okay, so it is called the conjunctive normal form. Okay, this is called the conjunctive normal form. For example, if I say that my statement is P, Q, and P and Q, and if I say that P plus not P and Q, if I write like this, so it is and means whenever I write plus, you can think that it is R. So is it in this particular form? Answer is no. How can I convert it to the conjunctive normal form? So again, conjunctive normal form, you know that P can be distributed inside. You can say that P R minus of P, okay, and PRQ. You can write like this. Am I right? I think I have done wrong. Here should be R, na? So now it is conjunctive normal form. Here, since there P and P are not P is there, so you know that if P and P is actually P, P and not P is equal to what? 0. P and not P, at least one of them is going to be 0. It is false. Okay. P R P is equal to P, P R minus P is equal to true. So true and P is equal to P. Okay, so this goes away. You can see that this. However, multiple terms are there. You can write like this. So conjunctive normal form. How can you convert the things into the conjunctive normal form? There is another way that tells that implication free. Do we want implication free? So implication elimination you can apply. How can you apply remove these implications? You know that R implies Q can be written as minus of R or Q. Am I right? So by this implication goes away. Negative normal form. So no double negation if it is a negative normal form, because double negation can also appear into the equation. If so, if there are no double negations, so we say that it is in into the NNF, negative normal form, NNF. Okay, implication free, conjective normal form. So I can give some statements so you can convert it to this particular form. So they're very simple. So few examples are there. So try to find out their conjective normal form, their implication, make them implication free. Okay. For example, here you can see that where there is a statement, so there is a implication. So how can I remove this? This part is negative and then r of this particular part. Here also minus r of q. Then you can open it and make it something like this. So it is it is a negative normal form and implication free. Okay. So for example, here is a question: find out the implication free A. So A is this. So implication free. There is double negation. You remove that negative. So sorry, implication free means this particular part. NNF means negative normal form means double negation you remove. So if you take inside, then and becomes R and double negation comes here. So this being removed. Okay, so in this way. Now I wanted to tell you a very interesting thing that is very important, and this is called the Horn clause. And Horn clauses are very important in the sense that there are few things such as Horn clauses are this thing that if there could be a clause or there could be a clause and Horn clause. So what does it mean? That there is a clause or clause and Horn. So multiple Horn clauses can be combined using and. This means what? This is the Horn clause. Okay. And what is C? C is something like A implies B. A implies P, something. A implies B implies P, something like that. And A could be anything, sir. This, for example, P and A, something like this. And then P, this P part could be true or contradiction or PQ or anything statement. Let me give you some example and the importance of this particular thing. So hope you can see this particular part. So importance of this particular part is actually, let me tell you, that is very important. So this is, so here is a Horn clause. Okay, here is a Horn clause. Control C. Okay. So here is a Horn clause. Okay. So what we can do with this? Control X, Control. So if I write something like this, so let me tell you that. Can everybody see this? Can you see this? Yes or no? Can you see this?
Yes.
It is small. Should I make it big? Oh my God, not becoming good. So actually says that here this is a Horn clause. So Horn clause says what? That P and Q and W is equal to tautology. This. So I don't know that what is the value of P, what is the value of Q, what is the value of W. If they all of them are 1, then we get what? Sorry, it is a contradiction. Okay, it is a contradiction. Sorry, it is a contradiction. So T implies contradiction. T implies contradiction means T is equal to false. P R implies P. Of that I don't know what is the meaning. T implies R means R, the value of R is equal to true. T implies Q means the value of Q is equal to true. U implies S. If U is true, then S is true. T implies U means what? U is equal to true. So I can apply this thing into this, that U implies S. So I should say in this particular way. Okay. Let me tell you once again. I say that initially I'm going to find out where the tautology is. This is tautology, this is tautology, this is the tautology. So I say that R and Q, forget about this, R and Q and U, they are true. Is it this clear? Because tautology is going to take them, because it's a tautology is going to provide you. So this is the information that you have. Now you try to find out, can you find out anything new out of available things? Can you find out anything in new? You can see that U implies S, and since U is true, therefore you get S is equal to true also. This part is clear or not?
Yes.
Then R implies to P. So you get P is equal to true by this statement. T is equal to T is equal to not. So this is false. Because directly T implies false. So what is the value of T? T implies false. P and Q and W implies false. So what is the value of P? P is equal to true. What is the value of Q? It is also 2. What is the value of W? I don't know. But they have to give what? Negative. So can you give me that? What is the value of W?
False.
False.
False. है ना? So this statement actually gives that what is true, what is false, what is true, what is false. These things can be given into this way. So again, there are multiple things over here. I ask you that please go through this and try to solve them. As I solved one, let's say all of them can be solved. Multiple examples are there. But this is a very important slide that I wanted to bring to you. So we have talked about the Wampus word. So if this was a problem that we have to solve. So we have single agent, deterministic, static, everything. So let me say that Pxy, if there is a pit in xy location, Bxy if there is a breeze in xy location, Wxy if Wampus in xy location, Sxy if there is a stinch in xy location. What we know that not a P11, not a P11, P11 means there is a pit in x1. Hey, very interesting thing. Please focus. You'd be very happy to see this, what I'm telling. So what I'm telling that what I have R1. What is the first thing that I have? R1 is what? That not of P11. P11 means what? If there is a pit in 11. So in the 11 there is no pit because it is a starting point. Okay. And R2 is equal to R2 is what? R2 is equal to B11. P11 implies and implied by P12 or P21. Breeze in 11 because 11 if you go into the B11 implies if there is a breeze in 11 it implies what? There is either pit in 1 2 or 2 1. Is it right? But breeze in 11 is false. We know that. We know that B11 is equal to false. There is no breeze. Okay. But do you understand this statement?
Yes.
Similarly, R3 is a statement that say that V21 if there is 21 there is a breeze, it means that P11 or P22 or P31. So similarly, you can understand this also. So this is the R4 next statement that tells that not of B11. This is C. This information we know that in B11 there is no stench. Sorry, breeze, no breeze. Okay. R5 is equal to B21 in the 2 1 in the 2 in the 1 2 in the 2 1 in the 2 1 there is no breeze. Whether we know it is true or false, we don't know. We don't know. So how many variables we have? Once again, P11 is a variable, B11 is a variable, P12 is variable, P21 is variable, B21 is equal to variable, P11 is already there, P22 is there, P31 is a variable, B11 is already here, B21 is already here. So these are the variables. We don't know that what is their truth value. They can be true and false both. 1 2 3 4 5 6 7 7 variable. So since you don't know and you want to find out that what is their value, you want to find out their value. If you find out all these values, then you would be you know everything about this particular place. Yes or no? If you find out this, if you write more variables over here, by this you explore more variables over here. If you find out all the values of all the variable, then you explore that. It means that you have explored the complete thing. You know everything about that. Yes or no? Yes or no?
Yes.
So ultimately your objective would be to find out what are the right values. So since you can apply true and false, allow true and false to them, 7 to the 2 different values are possible. Yes or no? I create a table where I'm going to write these parameters. Okay, B12, B21, B22, these 7 parameters. And I apply all of them false, then false, then true, then true, then false. So 2 to the power 7 different value I'm going to apply. Okay. So here what I'm doing, I am applying the 2 to the power 7, 2 to the power 7 different values to all of them. And then I am going to evaluate based on these values. I am going to evaluate that what is the value of R1, R2, R3, R1, R2, R3, what is the value of this. If this is my knowledge base, then this value should be true because this is my knowledge base. So I collect only those places where my knowledge value things are actually true. So these are the false, means they are the wrong assignments. So they are the possible assignments. So many of them are going to give me the positive possible assignments. So by this what I get that B11 in all the possible assignments is going to be false. It means that B11 is definitely going to be false. B21 is B21 in all the cases is true. I can say that B21 is equal to true. P12 is equal to false means P12 is equal to false. So you by this you can find out the parameter of all these values of all these values. How can we find out effectively? That is another problem. Right now I'm not solving about that. I just wanted to give you the idea that if you define the problem now please say with me that you are able to understand. If we define the problem in this way, can you define the problem in this way? Yes or no?
Yes.
Yes. If you define the problem in this way, then we can create this particular table. And by this
Yes.
table, we know that what are the things over there. Okay. Is it the best way? I'm not telling that. Okay. What is the best way? We can talk about later. So in all these, not of P12 is true, hence there is no pit in 12. On the other hand, P22 is true on 2 and false in 1, so it is not confirmed. So P22 is false in 1 and true in 2. So we are not still not confirmed about this particular thing what is over there. So similarly, we can find out that what is there inside the thing, and we can take the right decision to go ahead into the forward way. So this is the one way to solve this particular problem, that you do you define the things in using standard methods that we have seen, and we have seen that how deduction and all these things can be done on them. Using them, we can create a table and explore that what is the possibility, what is the right thing over there. Again, with respect to every statement, we can talk about there is two important concept, that is the validity and satisfiability. Validity is something that is always true. Unsatisfiability means I have a formula. Can you give me some assignment on which it is true? On other assignment, it may not be true, but some assignment it is going to be true. Then comes a very interesting idea, and that is called the forward chaining and backward chaining. And I think I would take it this into the next class. It is going to take just few minutes. I think it is not very difficult, but I think we have only 3 minutes. I will be able to cover it. So let's assume that these things are given to you. Okay, forward chaining. So determine if the single propositional symbol Q is entailed by the knowledge. So let's assume that few things are given to you. So, and I wanted to find out that some other things is given to you. For example, if P implies to Q is given to you. So you say that P implies Q. No. So let me tell you in this way. So let's assume that just a few statements are given in this particular way. Control A, delete, Control V. So few statements are, let's assume that given into this particular way, that that you are given something A. So you say that I have A. Some B is given to you. So you say that I also have the B. Sorry. I'm sorry. Right now I'm doing wrong. Let's assume A is given to you. Let's assume B is given to you. Take all these statements, okay? So A, and let's assume that it is given to you that A and B is equal to L. So you say that A and B is equal to L. So you got the L. A and P is equal to L. Let's assume that A and P is equal to L. So let's assume that there is some P, and when you combine it with the L, it is going to give you L. Okay. But this P, I don't know right now that what is the value of P. A was given to me as an independent thing. So I know that A is true. B was given to me, so I know that B is true. But for the P, I don't know. A and B is equal to L. Since A and B both are true, so I know that it is true. A and P is equal to L. So I don't know what is the value of P, but when I combine A and P, it gives true. So only possibility is that P is equal to true. Am I right or not? B and L is equal to M. So there is some L. This is L. So B and L, if I combine, then it gives me what? M. L and M is equal to P. L and M is equal to P. So what is the value of M? It is true because L was true, B was true. So by this also I can derive that the value of P is equal to true. So P implies Q. So P implies Q. If there is P implies Q, it means that Q is there. If the statement is that P implies Q, so since P is true, it means that Q is true. Q is there. So this particular method is called the forward chaining. By this we can do a deduction and we can find out that what is new things I can create and find out that what is the validity of those things. Okay. Similarly, this is a backward chaining, and into the forward chaining, as I have done, this method is called the forward chaining. Similarly, I can also do something called backward chaining. In the backward chaining, what happens that you go from the backward. Let's into the same problem. You want to find out that whether Q is there or not. So you actually start by saying that since P implies Q was there, so you wanted to find out what is the effectiveness of B. Okay, if somebody gives you that L and M is going to give you the P, so you create the tree into this particular way. If L in this particular way, here this says M is equal to B and L, B and L. So you combine by this. M is equal to B and L. I'm sorry, क्या कर रहा हूँ मैं? So I have M is equal to B and L. L is equal to A and P. So there is some A and there is some P. From here we come to this particular thing. So this we came into this particular way. From here we came here. So we don't have anything till now. Okay. A and B is equal to L. So A and B are going to give you the L. They are going to combine and give you the L. Now I have A. So when A is there, A is true. I don't have anything. Then I have B. B is now true. So they true means this is also going to be true. True and true means this is also going to be true. Okay. This is also going to be true. This true and this true makes this thing true. And this true makes P implies Q makes this thing true. So this is the another way of finding out the solution. So forward chaining and backward chaining. So I think we are done here. So then I would stop at this particular moment and just I would take this first order logic into the next class. However, I wanted to tell one thing and just give me 2 minutes to just finish. So Prolog is a language that is a logical programming language. You can go to this particular website swi-prolog.org. From there you can download the compiler and execute it. And you can write a program in any file such as a.pl, and these few are the operators, such as this operator is if operator, the comma is operator, and operator, and not operator is not, and this is our operator. So in this language, what happens now? You can define by yourself something. For example, penguin warm-blooded. So penguin is warm-blooded. Warm-blooded human. Human is also warm-blooded. Produce milk penguin. Produce milk human. Have feathers penguin. Penguin has feather. Have hair human. Human has hair. Mammal X. Now this is a now this is a function that tells mammal X. Mammal X means X is a mammal. So what are the properties it has? So this is the part. Dot actually says that function start from here, function ends over here. So I have given a function mammal X. So this function says that warm-blooded X. If I want to ask mammal anything, so that particular should have warm-blooded. That particular thing should have the produce milk and have hair. So if I do like this, I can ask from this particular system that mammal penguin, if I say like this, so it is going to test that whether it has warm blood, produce milk, and have hair. So penguin, I think, have feather, milk, and blood, so does not have hair, so it says no. So you write this code, and after that you can ask from this, and the system actually does the inference for you and give you the answer. If you call mammal X, so for all the possible X, it is going to tell you that which can be assigned a value, and those things it provided. So if I ask mammal X, so it gives me the human, because human have all these property, have hair, produce milk, and warm blood. You can also write some functions into different way, and input output is also possible. So I request you to please go and see this thing, see this website. There are various huge number of tutorials are available. That takes only 1 hour to teach all these things. So I request you please see the program prologue thing and try to make something. I would be giving you an assignment today, and that would also include a part from the prologue. Okay. Hope you all are good programmers and you can learn it very easily. So I just wanted to show you to you. Thank you very much for joining this session. Hope you